Now we have all the accuracies, okay, but we want to select the one with the maximum accuracy, right? And by the way, you can, if you want, instead of accuracy you want something else, then you can calculate that, because sensitivity, if you want sensitivity, then so you have to calculate the sensitivity from the, you have all the information that you need in the confusion matrix, so you have to calculate that and save it, okay, or any other accuracy measure that you want. You can calculate and save it, but accuracy is already there. We don't have to do any computation. All we have to do is to extract it and save it, which is what we have done here. Okay. So now we need to figure out what that k is. Okay. So let's call it best k. Okay. So I'm using uppercase k here, so you have to remember, make sure that we keep the lower and uppercase correct. So we have a method called which max, and then there is which min. If you're looking at error rate and you want the minimum, then you would use which dot min. So now we want which dot max, okay, and then we give it the object that you want to look at. So that would be knn accuracy, okay, and the column, there are two columns here. We want the accuracy column. Okay. Now, the k value and the rho value are all the same. So we don't have to say anything more, but if that's different, then you can say okay, like that. So then it will give you the value from the first column, but we don't need to do that. So, and then let's say we want the best k to be printed. Okay, so it's the first one. Okay. And well, if you want what that best value is, then we can say knn dot accuracy. All right. So then we say best k. Now accuracy is in the second column. So say 2. So that will give you the accuracy corresponding with the best k. Okay. So how many neighbors should we consider? Okay, so this is how you would decide. So you'll have to run through. Okay, we did k equal to 1 through 20. You can do k equal to 1 to 50 if you want. If you have a really, really large data set, you can even go higher if you like. Okay. Then here, in this case, the accuracy starts off with 97% and it gradually goes down. So k equal to 1 seems to be the best here, but k equal to 1 has some problems. So here you're looking at each, so the probability is going to be 100% for each row, because you're looking at only one neighbor. That one neighbor, if the class is 0, that's 100% probability is 0. There's only one. And then if it is 1, then 100% probability it is 1. Right? So k equal to 1 is kind of problematic, but anyway, so this is just a demonstration how to run different k values. So this is kind of a iffy situation here.
Is that because this is stop data?
That doesn't stop what?
Is it because of the data?
Yeah, it is this particular data. Yeah, yeah. This data happens to be like that. So it's not going to be like that all the, it could be different. But even here, if you use different methodology, this could change. Okay. Here we are looking at just train data and validate data. So if you use cross-validation, this could be different. We may get different results. Okay. But k equal to 1 is problematic though. because it's just looking at one neighbor.